So if we are looking at our different types of triangles, okay? Things you want to keep in mind are different things about triangles. Today we're going to talk about interior and exterior angles with our triangle, and we're going to justify how triangles are similar. So what is the correct definition? I want you to think, mathematical definition of a triangle. What do you think has to be the case? You can see many triangles here. What do you think the definition of a triangle has to be? Talk to your shoulder partner about things that make it a triangle. And you can talk either way, in front of you or behind you. All right, are we ready to give some answers? So raise your hand if you and your partner have at least one thing you can tell us. Daniel.
180 degrees.
That's not a definition of what makes a triangle, but I agree that the interior angles, so one thing that we know, this doesn't really define it, but the interior angles must sum, means add, to equal 180 degrees. But if we're defining it, what might be a definition? What's something thing?
A three-sided figure.
It has to be a three-sided polygon. And it actually has to be a closed figure, right? So a three-sided, I heard some groups use this word, closed polygon. That means it can't have three sides and then one of the sides be open as you are looking at that, okay? Anything else that makes it a triangle? So when we look at it, it's a three-sided polygon, and yes, the sum of the interior angles are 180. And we're going to talk about some other characteristics as we look at this. So when we look at going down in that next part of your notes, we have different types of triangles by angles. So tonight in your homework, I am going to be asking you to identify the triangle by its angle. If you are looking at identifying it by its angle, an acute triangle has three acute angles. Remember, the definition of acute angle is where we have an angle between 0 to 90 degrees, okay? So acute angle means it has to be bigger than 0 and less than 90, right? So all of these angles going around here have to be acute. They don't have to be the same, they just all have to be less than 90. For a right triangle, you need one right angle. This is our right angle down here, right? They show it by showing that perpendicular. And then obtuse has one obtuse angle. And so kind of going back to what Daniel was saying is that our angles can't be more than 180 degrees. And that means you can only have one right angle, right? Because these other two angles have to sum to 90. So you can't have two right angles. Here is going to be our obtuse angle in this picture way down here. And remember that definition of an obtuse angle just means that it's an angle that's between 90 degrees and 180 degrees. Now, it is not 90 and it is not 180, but it is between those two, right? Because you could have a 91 degree angle or 90.5, and then you could have the other one, okay? So keeping that in mind, a 90.5 degree angle is going to be an obtuse angle. You are also going to be asking your homework to classify your angles by their sides, meaning if you have an equilateral triangle, you are talking about all the sides being equal in length. Isosceles triangle, you may remember some of these from last year or from 6th grade. Isosceles is when two sides are equal. And a scalene has no sides the same. So these tick marks kind of show the same lengths. This one might look something like this. You might have three different marks, just telling you that you have three different side lengths, okay? If you were going to read this next part, go ahead where it says a geometric.
A geometric figure can be named using the vertices of each of its angles using either clockwise or counterclockwise order, such as ABC or EDF.
So when we read those, we're talking about triangle ADC, triangle EDF. It says the tick marks on the drawing show that the sides are equal, marks that show the angles are equal also. So this is showing us that we have this isosceles triangle. This one is showing us that we have an equilateral triangle. All three angles are the same. Usually equilateral are also going to be equal angular, so that all these angles are the same. So in this case, if I know all three angles have to be the same, I know that each angle has to be 60 degrees, right? 60 times 3 gives us 180, right? So 60 times 3, because I have three angles marked the same. All right. So if we are looking at this, this is kind of going back to what Daniel was saying with those angles being equal to 180. I'm just going to watch this video. We're not going to watch all of it, but it kind of shows how if you are looking at a triangle and if you would rip these three parts apart, the triangles apart so that you can put the angles along a straight line, kind of how many degrees should they form? That kind of helps us to look at this next part. So as you are looking at this, you should right now, by looking at your notes, be able to classify the triangle by its angle. So looking at these two, we're going to find this angle.
Why do triangle angles always sum to 180 degrees? In this lesson, you will learn about the interior angles of triangles by looking at their properties. Let's do a quick review. The three angles of a triangle always sum to 180 degrees. 98 plus 42 plus 40 equals 180. It also works with acute angles, and obtuse angles, and right angles. A line or segment that passes through at least two parallel lines is called a transversal. In this case, line AB is a transversal to line CD and line EF. Transversals create very special angle properties. Angle AGC is an alternate exterior angle to angle BHF. They are alternate because they are on alternate sides of the transversal, and they are exterior because they're on the outside of the parallel lines. Any two angles that share the same position on the transversal on the same sides of two different parallel lines are called corresponding angles. Angle CGH and angle GHF are alternate interior angles. They are on alternate sides of the transversal and they are inside the set of parallel lines. Alternate interior angles are always congruent. Triangles share many of the same angle relationships because every triangle can be formed this way. Start with a set of parallel lines and then add a transversal. Next, we'll create another transversal that intersects the first transversal at the parallel line. This creates a triangle. This triangle began with a transversal, and line AB also created a set of alternate interior angles. We know that they're congruent, so we can label them both angle 1. We'll label this angle angle 2 just so it isn't left out. The other transversal, AC, also created a set of alternate interior angles, and we know they are congruent to each other as well. We'll label them both with a 3. Look how amazing it is that you can make a straight line from the same three angles of a triangle. You can try this with paper triangles too. Cut out a paper triangle, tear off the vertices, and line them up in a straight line. It works every time. This is one way that we know that the three angles of a triangle must sum to 180 degrees every time. Now let's apply this knowledge to a problem. Find the missing angle measurement. We are given two measurements and have a variable for the third. We know that the angles sum to 180, so we can start by adding the two angles we know. 89 plus 68 equals 157. Now we can subtract 157 from 180, and it equals 23. So x equals 23 degrees. In this lesson, you have learned about the interior angles of triangles by looking at their properties.
So if we are looking at that, and we want to finish this problem then. So we are looking at it, and if we're classifying it by its angles, first off, 42 and 42, we add those together. We're going to have 84. We're going to take 180 and minus 84, which should give us how many degrees for x, Layla? What'd you end up with? 96 degrees. So we're going to have 96 degrees. So we are going to say that the measure of angle x is equal to 96 degrees when we subtract those two. Because this angle is 96 degrees, how would we classify our triangle, Brett? By angles. We have 96, 42, 42. Look back on your page before at the type of angles. Going by angles, what would you classify it as? Okay, so when you look at, that's dealing with sides, right? Look above there where it says angles. By angles. So by angles, we're looking at acute, right, or obtuse by its angle. So that's probably the most common mistake that you did also. It is going to end up being isosceles, but we want to classify it by the angles only. So you call it what? An obtuse triangle. So I am going to ask you to name them by the angles. When you're asked to name by the angle, that's obtuse, right, or acute. Someone said, oh, but you have two acute angles. Yes, but because of the one obtuse angle, it makes it an obtuse triangle. Okay? Is it also isosceles? Yes, but that's dealing with the sides, not the angles, right? So I don't ask you to classify it by its sides. So, I mean, if you put that down and that's the only question I ask you, then I'd have to mark that wrong. So the other thing we're going to be looking at is how this exterior angle is related to the two interior, or the three interior angles. What do I know if this is 68? What do I know about these two angles together with x? How many degrees do they make, Grace? 180, because they are supplementary as we are looking at those. So we're going to watch this again. It's pretty short, but they kind of explain through some of it, so kind of take.
How can I make a skateboard ramp that is 160 degrees with the ground? In this lesson, you will learn about exterior angles by exploring how they are related to triangles. Let's do a quick review. The three angles of a triangle always sum to 180 degrees. The same is true whether the angle is acute or obtuse or right. An exterior angle is formed by extending a side of a polygon. The measure of the exterior angle is related to the interior angles of a triangle. Let's see why. We already know that the interior angles of the triangle must sum to 180 degrees. We also know that since the interior angle at point C forms a straight line with its extension, the interior angle next to the extended side and the exterior angle must sum to 180 degrees. In order for both of these equations to be true, x must equal 29 plus 83, or 112 degrees. Therefore, any exterior angle is equal to the sum of the other two interior angles. Let's use this knowledge to solve a problem. Find the measures of angle CBD and angle CDB. To solve this problem, we need to use the information given to us. We know that the exterior angle from point B is 106 degrees. Angle CBD must be equal to 180 minus 106, or 74 degrees.
Because we're knowing supplementary, right?
Now that we know two of the interior angles, we can find the third angle. Angle CDB must be equal to 180 minus the sum of 76 plus 74, or 30 degrees. The answer to the problem is angle CBD equals 74 degrees and angle CDB equals 30 degrees.
We usually use that angle symbol there, or the
Now
measure.
let's look at the beginning problem. The stick man was asking, how can I make a skateboard ramp that makes a 160-degree angle with the ground? Here's a drawing of his plan. Since we know his exterior angle, we also know that the interior angle must be 20 degrees. As long as his ramp connects with the support at a 90-degree angle and he forms a 20-degree angle with the ground, he knows that his exterior angle will be 160 degrees. In this lesson, you have learned about exterior angles by exploring how they are related to triangles.
So when we are taking a look at this one, as we take a look at that, the question is, as we are looking at blank angles extended out the side, that should be our interior angle is next to the extended side. And if we are looking at that, then it says the exterior angle must sum, if we are looking at that, to give us 180. So that we know 68 plus x equals 180. We should be able to find x degrees. The other thing we could have done is we could have added 29 and 83. Does it give us the same answer, 29 plus 83, if we are looking at that? What do I get when I sum Wyatt and add 29 plus 83? Do I get the same as if I take 180 and subtract 68? What'd you end up with? 29 plus 83 gives us 112. Do I get the same thing when I subtract here? Yep, exactly the same, right? So I can add, if I know the two opposite interior angles, those will always sum to the same as this angle, or I can take 180 and minus that number. All right, so you're looking at this next one. Some of you, as you are looking at yours, it says you're asked to find the measures. When you give BCD or CBD, that means that this B has to be the vertex. We are talking about this angle right here for finding that. So right now, kind of do this one, and I'm going to give you a couple, like less than a minute, to kind of work with your shoulder partner. Look at that angle. Next one you're going to look at, so the angle of CBD, what do we know about that one? And as you're kind of thinking that one through, one of the first things we know is that it has to be 180 minus that 106. So what are you going to have for an angle measure? Please fill that in as you are looking at yours. Do you have something to write with? Who doesn't? Do you have a pencil? I have other ones if that's not working. Okay. So find that angle. Next, if we are looking at that one, what'd you end up with, Sage? CBD, 180 minus 106 should be? 174. How about just 74? Can't be 174, right? Should be just 174. I had some of you do that on the quiz the other day, so be really careful as you're doing that subtraction. If I'm now looking at C to D to B, that's this angle here, I should be able to take, there's two ways of finding it. One way is taking the 76 plus 74 and subtracting from 180, right? So once we know one of our angles, and some of you, I would suggest that you write it in here. You don't have to. If we are doing that, Ellie, what am I looking at for a solution? Yep. Should be how much? CBD should be 74.
Oh,
right? And then CDB is going to be, so that's this one way in the corner.
no, 30.
Should be just 30. Okay. So we knew from here these two are the same angles, right? That's 74. This is just asking us to write it again. I won't have you write it that much when you're looking at your homework. So here we're going to talk about the angle similarity. It says if two angles of one triangle are congruent to two angles of another one, then both triangles must be congruent. So if two of them are the same, the third angle has to be the same. This is called our angle-angle similarity. So when I look at these two angles, if these two are the same, and over in this picture they're the same, now they're not necessarily going to be exactly the same. They're not necessarily congruent triangles, they're just similar. So the sides are still proportional. So if we are looking at a triangle like this one, it's asking us, are the two similar and how do we know? So we're going to take a look at this video. Again, it's pretty short, 2 minutes, that we're going to take a look at. And today's lesson has lots of videos.
Are triangles congruent if they have the same angle measurements?
In this lesson, you will
learn about similarity by comparing triangles with congruent angles.
Let's do a quick review.
Congruent figures have the same shape and size.
These two triangles
are congruent.
Similar figures
have the same shape, but not the same size. These triangles are similar, but not congruent. Similar figures are proportional. Notice how the orange triangle's sides are double the size of the blue triangle.
Are triangles
congruent if they have the same angle measurements?
Let's look at an example.
If we start with this small triangle and then extend each side,
we can create a
larger triangle by drawing a parallel hypotenuse.
So the angles will have the same
measurements,
but the sides
do not.
The sides are
proportional, but they're not the same length as the first triangle. So these triangles are similar, but not congruent.
Let's try a word problem now.
Triangle ABC has angle measures of 58, 58, and 64 degrees. Triangle DEF has measures of 64, 58, and 58 degrees. Are they congruent?
Here is what
triangle ABC might look like, and here's how triangle DEF might look.
The problem
didn't give us any size lengths, so we can draw them any size we want. Also, the order of the angles does not matter because we could always rotate and or flip the triangle to make them match up. But remember, we also could have drawn them as congruent triangles. So the answer to the question is that there is not enough information given to have an answer of yes or no.
In this lesson,
you have learned about similarity by comparing triangles with congruent
So we want
angles.
to take a look at, if this is 39 and this is 90, what does this one have to be? And if this one is 51, what is this one? So please, with your shoulder partner right now, find these two missing. We really just have to subtract from 90, correct? We really only have to subtract 90 minus 39 and 90 minus 51 if we are looking at those two, right? So please do that, find the missing, write it in on your triangle on each one. Write in what that missing one should be. So if we are looking at it, what did you have, Courtney? For the first one, we had, you took 90 minus 39. You got 61? Okay, so do that subtraction, check with your shoulder partner. Okay? Yeah. Yep. Can you win? We're looking at this one, we have 51 degrees. Here we're going to take 51 minus, so it means it should be the same, right? 39. Are the two triangles similar? We are going to put yes. Our reason, because the missing angle, and if you want to use this instead of writing out the word angle, I'm okay with that. On the smaller triangle, you should be writing this. Some of you are moving your pencil if you don't have anything like this. Smaller triangle must be 51 degrees. So both triangles have a 90, a 51 degree, and a 39 degree. So by what's called our angle, similarity, the triangles are, in this case, similar. So when you're doing your homework, you're going to kind of do it in the same way. We're going to practice two more of them that you're going to take a look at. And then I'll take a look at your quiz if there are questions. Now, when you start looking at these, you want to apply what you know about how the two lines are set up or how these are. So if I am looking at angle WSR, what do I know about the measure of WSR related to, on this other triangle, to another angle? So we know these two are equal. WSR, what do I know about this angle to the angle on the other picture, on this other triangle? VSB or VBS. What do I know about this angle at S, from V to S to B? What kind of angles are they when they're directly across from each other from last week when you did them? Ben, you remember? They are what?
They're the same.
They are the same. Called what kind of angles? When they go across like this. They have a special name. Who remembers? Raise your hand. What do you got, Grace?
Vertical.
They are vertical angles. So these two angles are going to be congruent because they are vertical angles. So what we're going to say is we're going to start off and say something like this. Angle R, we already can see from this picture, is congruent to angle V. Why? Because they were both 45 degrees. And we now know that angle RSW is congruent to angle. And if we go from R to S to W, we want to make sure we start at V to S to B. So we're going to go V, S, B. Are congruent, and the reason they are congruent is because they are vertical angles. So, why are those two congruent? Because they're vertical angles, which are always congruent to each other. And so now we can say, so triangle RSW is going to be, in this case, not congruent, but similar to triangle VSB. So when you do your homework, you're kind of doing, this is like when you get into geometry in a couple of years, you do these formal proofs. This is how you're going to be doing them. So in this one, first in each picture, find your missing angle. Find your missing angle. Find what P is and find what K is. Are our triangles going to be similar? And remember, to have similar triangles, you must have two angles congruent. In the first one, if you had done your subtraction and found your angles yet, do so. What'd you get? What'd you get? What's the missing angle on the first one?
First one. 70.
Well, this is 70 down here, and this is 30. Yeah, so next time don't fill in your notes, do it while we're in class, okay? Okay, yeah. So, 100 plus 100 subtracted from 180, how many degrees do you have to have up here? Yeah. You wrote it down already. You just have to look at what you wrote down. What'd you get for this missing angle?
80.
80 degrees, okay? Carmen, if we're looking at this other one, what'd you get? You're going to add those two together, right? Subtract from 180. What'd you end up with? You guys have calculators there too if you need them. So we're going to add 70 from 85, subtract it from 180. What do we end up with? So do we have, if we are looking at this one, so if we are looking at this one, are we going to have similar triangles? So the only thing we know, are our triangles similar? No. Not similar. Because you only have one angle congruent. Angle L was congruent to angle R, which was equal to 70 degrees. And the other two angles were not the same. In each triangle, they were not congruent. 80 is not the same as 85, 25 is not the same as our 30, as we are looking at that. Okay? So in your homework, what are you going to be looking at as you do the homework? We got one more practice thing to look at the bottom of this page. And then we'll kind of be talking about what you need to know for the test. We really don't have many more new lessons. The rest of this is just kind of reviewing this week that we're going to be working on. So it says, determine if the two triangles are similar. So I want you looking at each one of these and trying to determine, are they similar? What do I know about these two lines? They are parallel. And if it helps you to extend the lines, we should be able to see alternating interior. We should also be able to think of seeing, as we look at these two, our vertical angles. So right away in these two triangles, I know these two angles are congruent because of vertical, right? So I know those, I have two congruent. Can you tell me another pair that will be congruent inside our triangle? Yeah.
C and D, they're 90 degrees.
Not necessarily 90, but what we do know is that angle B and at angle C, they will be congruent because they are, what kind of angles? Alternate interior. So these are our alternate interior. These were our vertical angles right here when we were looking at. And all we have to show is that two angles are congruent. Could I have had at angle A and D, those were also alternate interior, right? So we need to put them in the right order. If we start from A to B to E, talk with your shoulder partner at which angle I must start with and be ready if I call on you. So starting at A to B to E, what do we have to start on this triangle? Talk with your shoulder partner, we're going to write it down. So, if I started A, it had no marks, right? I went to B with 2 and E to 1, which means in this one, I must start, Haley, where? D. Yep, keep going. D, C, E. If you would have started this one at B and went like B, A, E, then you'd have to go C, D, right? So it just depends which one you start. I will take any answer. As you look at this one, what kind of angles between parallel lines do you know these two are? Sophie, if we're looking at those. At angle P and angle M, if those are my two parallel lines, what do I know that those are? What kind of angles? What was the word? Between two parallel lines. This is my transversal that's cut. What are these two special names of these angles? In the same spot. Corresponding. Do we know corresponding angles are congruent? Right? So angle P and angle M, right now these two are corresponding, which means they are congruent. Do we have another set of corresponding angles? And what I want you to think about is if you draw these two triangles, here's the big triangle, triangle MLN, right? Here's the smaller one, OPN. Do they have anything that's exactly the same in both triangles? So we just said these two angles were congruent. Isn't angle N going to be exactly the same measure in each one? So you have this big triangle and this small triangle. If I start with the larger triangle and I call it triangle MNL, what is it going to be congruent to? And I could have used corresponding angles for this angle also, right? These are corresponding. These two are the same. So if I'm giving this one, what do I have to have it being, Braden? M to N to L, what is it going to be on my small triangle? If I go M, P, N, O. Okay? Looking at that last one, please find with your shoulder partner your missing angle. Tell me if they are similar or not. Find the missing angle on each triangle. And if you find it on one, you might not even need to find it on the other one, right, if it's not the same. So you have 76, 48. You either have to get 63, right? Or it's not going to be similar. What do we get? Avery, did you get it? Okay. So add 48 and 76. Subtract it from 180. What'd you get? $56. And 56 is definitely not the same as 63, right? So if we are looking at it, can we say our two triangles are congruent or are similar? We would say that they are not similar if we are looking at this one. Okay? So you're going to be asked similar or not. Now, tomorrow we go to scuba, or you have your in class for your activity. As you look at these in your homework, what you are asked to do, they are not hard questions. You are asked to identify it by its side length here. Here it says find the value of x and name it either right, acute, or obtuse. So here they're telling you equilateral, isosceles, or scalene. Here it says use similar figures or similar relationships, find that value of x, so use what you know about your triangles. And then, so it's the front and back of this page. And then this last one, you're asked to determine if they are similar. If they are similar, what I want to see is something like in our homework, in the notes that you did, or you tell me this. If they're going to be similar, you need to be able to justify it. How do you know? That's this part I need to see. If you did not turn in 16B last week, I need that back here. There's some of you still that have not turned in